Hey guys, so we're going to start this next lesson, 2.5. Please open up the notes from Schoology, and we're going to get into a little bit of proofs here, and we got these things called postulates. They're kind of like theorems, okay? So, I got some jazz music going on so it's not boring the whole time. Hopefully it's not putting you to sleep. You can rewatch this video as many times as you want, and I'm not going to make a bunch of them just whenever I'm absent and we need to go through a lesson. Alright, so we got some postulates, kind of like some theorems here, and we're just going to go through each one, okay? And I'm going to highlight a few things here that I want you guys to highlight as well. So postulate 2.1, it says, through any 2 points, there's exactly one line. So if we have 2 points here, any 2 points, we can draw exactly just one line, okay? So those are some things I want you to underline or highlight, whatever you want to do. So just 2 points, not 3 points, not 4, just 2. 2.2 says through any three non-collinear points, there's exactly one plane. Right? Remember we would say this plane here would be like planes ABC, right? Planes ABC. You needed 3 points to label a plane, right? Not 2, not 1. You can't just say that's plane point A, right? You can't do that. And actually this is actually plane K, but K is not a point. That whole piece of paper is a plane. Okay, remember we call the plane a piece of paper? Okay. Next one here, 2.3, postulate 2.3, a point contains at least 1 point. Sorry, at least 2 points. Okay, a line contains at least 2 points. So that means 2 points or more. 2 points or more, right? So you see here we have 3 points, P, Q, R. So as long as as long as it has two or more, it could be on the same line. It also could be not on the same line too. We'll talk about that later. 2.4, a plane contains at least 3 non-collinear points, right? 3 non-collinear. At least 3 non-collinear, so 3 or more. So there's some differences between the first 4 here, right? So if you look at 2.1, it says exactly 2 points. Just 2 points and only 2 points, right? And if you see 2.3, it says at least 2 points, 2 or more to make a line, right? And 2.2 says exactly 3. Sorry, we should have highlighted exactly as well. Exactly 1 plane for exactly 3 non-collinear plane points here, right? And then 2.4 says at least 3 or more, right? 2.5, if 2 points lie in a plane, then the entire line containing those points lie in the plane. So if 2 points lie in the plane, points A and B, then the entire line containing those points lie within that plane. In this case, it's lines points A, B, which create a line M, which lie on plane K. Okay, and you can read all the information there on the right, and we're going to refer back to these guys too. So 2 points lie. So 2 points lie in the plane, and then the entire containing points lie in that plane. Right? We have 2 more. They're pretty easy, very common sense. 2.6 keywords here. 2 lines intersect. Right, now we have these things intersecting. So when 2 lines intersect, they create exactly 1 point, right? So 2 lines intersect, they create exactly 1 point, just like cars colliding, right? Now let's go to the last one here. If 2 planes intersect, two pieces of paper intersect, 2 planes intersect, then they create a line, okay? So make sure you guys have that underlined, because we're going to go straight into the first example here. So, example 1, explain how the picture illustrates that each statement is true. The statement then state the postulate can be used to show each statement is true. So, part A here says line M, take a line M, it's a vertical line right here. Okay, this guy right here, right? Line M, this guy. Line M contains points F, G down here, and then it says points E can also be in the line. So it has 3 points right now. Okay, 3 points. So we got to figure out which postulate is talking about a line and something that has 3 points. Or you could say more than 2 points, right? I want you guys to think about it, look back, see which one is talking about a line. The postulate that talks about a line is 2.1 and 2.3, right? But in 2.1 it's talking about 2 points and exactly 2 points. That's it, right? In 2.3 it says at least 2 points, so 2 or more points. So the postulate that we can say that states this guy for part A is postulate 2.3. We can abbreviate postulate. You don't need to spell it out all the time. So postulate 2.3, right? It's talking about 2 or more points. Alright, next one here. Lines S and T intersect at a point. Lines S and T. Here's lines S. Here's lines T. Intersect. The only word that use intersection in our postulates here were 2.6 and 2.7. Intersects. So, and they're talking about lines intersecting. So lines intersecting and creating exactly 1 point. Okay? I hope you guys can see it, but it is postulate 2.6, right? If two lines intersect, then intersection exactly 1 point. So this is postulate 2.6, okay? So we're just matching up the postulates with the scenario, pretty much. Next one here, points A, B, C determine a plane. So points A, B, C determine a plane. So let's figure out which one is talking about a plane here. Let's look back at our postulates and see which one is talking about planes, right? And 3 points. So 2.2 is talking about a plane and 3 points and exactly 3 points. Okay. 2.4 is talking about a plane and 3 points or more. But right now we're only dealing with exactly 3 points. So the winner here is postulate 2.2. Right? If they gave us 4 points, like points A, B, C, D on the plane, then we could say, you know, postulates 2.4. But right now, it's only 3 points. So postulates 2.2. Hopefully this makes sense, because it's exactly 3 points only, right? You can make a side note here, you know, 3 points if you want. Alright, last one here. D, planes PQ intersect at lines M. So let's find planes PQ. Planes P and Q. I'm gonna erase some stuff here. Take a look where the planes are at, guys. So here's planes P. This is all planes P here. Side of that building. Alright. And here's planes Q right here. Right? Other side of the building. And they intersect at lines M. Lines M is all right here. Right? Two planes colliding and they intersect at lines M. Let me get back to it. Okay. So we're looking for the word intersection. We're looking for something to do with planes here. And he created a line, right? So looking back here, intersection in a plane, it's got to be postulate 2.7. It's got to be. So postulate 2.7. Two planes create a line. So this was just a warm-up for us. Hopefully that wasn't too bad. We're going to move on to the next part here, example 2. Determine whether each statement is always or sometimes or never true. Explain your reasoning. So if you need to take a break, you can take a break, you pause it, but just start watching it when you're ready. So it says, if two coplanar lines intersect, then the point of intersection lie in the same plane as the two lines. So two lines intersect. If two coplanar lines intersect, so we're going to draw a plane here. Okay. And say in this plane, there are two lines that intersect. Okay? If two coplanar lines intersect, then the point of intersection lies in that same plane. Think about that. If you got two lines that are on the same piece of paper, do you think their intersection is going to be on that piece of paper still? If you said yeah, then you are correct. This point of intersection, because since those two lines are on the piece of paper, that means that their intersection will also be on that paper. Okay? So this is always. It's always going to be on this piece of paper. And why? What postulate is talking about lines intersecting and being on the same piece of paper? Postulate, take a look at it. Or having a line in a piece of paper, postulate 2.5. Right? 2.5 and 2.6 here. Postulate 2.5 and 2.6 is intersecting lines, right? So because of postulate, you say because postulate 2.5 and 2.6, right? Alright, so let's go on to the next one. 4 points are non-collinear. Remember the word non-collinear means not on the same line. I forgot to talk about coplanar. Coplanar means they are all on the same line. So non-collinear means they are not on the same line. So are 4 points always going to be in the same line, or 4 points sometimes going to be in the same line, or are 4 points never going to be in the same line. So let's think about it. So I'm going to make one example here. One example, 4 points being in the same line. These are 4 points that are on the same line. Can I draw them where they're not on the same line? Just 4 random points. Yeah, I can draw 4 points not on the same line. This is not a line at all. So sometimes I could draw it on the same line, which is this guy, and sometimes I cannot, right? So this is a sometimes scenario. Sometimes. In which postulate talks about 2 or more points being on the same line. Goes a postulate 2.3. We're just trying to match up the postulate that matches up with our scenario right now. Okay? Now the next one. 2 intersecting lines determine a plane. So, do 2 intersecting lines always determine a plane? Or do 2 intersecting lines always determine a plane? Or do they sometimes determine a plane or never determine a plane? And think about it. How do we determine planes in general? What did we have to use to determine planes? Did we say lines A, B, C, D determine a plane? Or did we say points A, B, C, D determine a plane? Right? So if you're thinking about it, we always said points A, B, C determine a plane. We would say plane A, B, C, right? So if we have a plane here and we have 2 intersecting lines, this point here does not determine that plane. 2 intersecting lines do not determine that plane. So this is a never scenario. Never. And what scenario talks about intersecting lines and planes here? Postulates 2.6, right? 2 intersecting lines. Right? It doesn't determine a plane here. We can also have another one here. Let's see here. Postulates. What determines a plane here? 2.2, right? 2.2 and 2.4. So 2.2, 2.4 determine a plane. Okay? We can say or 2.2/2.4. Okay? 3 lines intersecting, 2 points. Do 3 lines intersecting always create 2 points? Sometimes create 2 points, or it never creates 2 points. Okay? Let's kind of go down the list here about creating 3 lines and their intersections. Okay? So we got 4 scenarios actually. So I'll give you one at a time. Here's our first scenario. Okay? Our first scenario, 3 lines where they never intersect. Here's 3 lines. They never intersect. Second scenario, they have 1 intersection. That's 1 intersection, just 1. Okay? Third scenario, there are 2 intersections. Right? 3 lines, 2 intersections. Last scenario, there are 3 intersections. Okay? So 3 lines intersecting at 2 points. This is the only one where it intersects at 2 points. So this is a sometimes scenario. Sometimes it intersects at 2 points. Right? Sometimes. And what scenario talks about intersecting lines? Postulates 2.6, right? Intersecting lines. Alright, so if you need to take a break, take a break. This next part here is going to be kind of confusing a little bit, but we're going to go into proofs, okay? So before we start the proofs here, I want to give you a simple and basic proof that we would normally do here. So, introduction to proofs. It's always going to be like this. It's going to be a pain in the butt, guys. They're always going to give you a given, right? And so this is our problem. They give us that the problem is 2x plus 1 equals 5. And we have to prove that x equals 2. So we're going to show a little bit of the work and explain it. That's what the statements and reason are, okay? They're going to ask you to prove using a paragraph proof. You don't ever have to do the paragraph proof. We're going to do a customary, traditional two-column proof. And it always starts out like this. We're going to write the word statements and reasons. And you guys don't have to write this out if you don't want to. It's going to look like this, like a chart, okay? And we're going to number them each time. So it's going to look like this. So the first guy, I'm going to write this out, number 1. The first step here is to write the given. 2x plus 1 equals 5, right? And we're going to write, why did we write that? It's because that's the given. That's what they gave us. So to solve for x here, I hope you guys know, we're going to subtract 1, right? So we just need to state what we're doing. So the next here, if I subtract 1 on both sides, I get 2x equals 4. And then you have to say, all right, what'd you do? Well, I subtracted by 1, right? And the next step here would be divide by 2. You don't really have to show that you're dividing by 2. We're just going to explain that we divided by 2, right? And we would say divide by 2, like that. That is a basic proof. You're going to have one of these problems in the next lesson, but I just wanted to give you guys an introduction to what you're doing here. Like I said, it's a pain in the butt to do, but this is how we're going to have to do it, okay? So with that being said, we're going to get started on our first proof problem. It's not going to be fun right away, and I already have the statements of reasons for you guys kind of lined up. So we have to write a 2-column proof. Regardless if they say to write a paragraph proof, always do a 2-column proof, okay? So the first part here says M is, the given part is M is the midpoint. M is the midpoint of X and Y. So I have points X and I got points Y. Connect them. So in between them is points M. So it says that that guy's a midpoint, okay? And we need to prove that XM is congruent to MY. So the first step here is to write the given. Okay? Write the given. So it says M is, you can abbreviate some of the stuff, midpoint XY. Okay? Just for writing the given stuff on the exam, guys, you guys get 1 point. Just like that. Okay? So what does midpoint do? Hopefully you guys remember what midpoint does, but midpoint says that I'm in the middle over here, so distance from here to here is going to be the same distance from here to here. Same distance. So what that means that this length, X to M, is going to be the same length from M to Y. So I can say X to M, line XM equals MY, right? And why were we able to do that? Because that's the definition of midpoint. That's what midpoint means. It's distance. So last part here is we just got to put the proof part. We just got to put the proof part right there. So we just got to say XM is now congruent to MY. And so we went from equals to congruent. And that's just the definition of congruency. We can just put that congruent symbol, okay? I got one more theorem that we can also use instead of putting definition of congruency. But the one more theorem here is midpoint theorem. And the midpoint theorem says if M is the midpoint of AB, then it automatically splits up AM is congruent to MB right away. So we could also put, for the third guy here, I'll put this in parentheses, theorem 2.1, which is the midpoint theorem, okay? And we can use the midpoint theorem again. So take a look at this proof, dissect it a little bit, look through it again if you have to. You only have 2 proofs to do. I want you guys to try it for homework. Alright, we got one more here, okay? So, given C is between A and B, and AC is congruent to CB, we need to prove that C now is the midpoint of AB. So let's do a drawing. So we have A, and we got B. That. So in between them, C is somewhere in between. It doesn't have to be directly in the middle. It could be anywhere, closer to A or closer to B, right? So let's just say C is right there, right? But now they tell us that AC is congruent to CB. So AC is congruent to CB. They give us that information. So the first step here is to write the given right away. Given. Okay? So we write all this stuff here. C is between A and B, sorry. Okay? And then we have another one here. AC is congruent to CB. Draw those lines over that. So that's the given. Okay? Our next step here is to say that we got to make an equation of AB. So I'm asking you what length plus what length gives us the whole length of AB. Right? So that's AC, the length of AC plus CB equals the length of AB, that whole length, right? Sorry, this is number 2. And this is the definition of midpoint. Or you could say, you know, line segment if you want to. Addition of line segment. Okay. And now we're just going to reiterate about the given part here. The AC is congruent to CB. Well, we can also say that AC equals CB. I'm not a big promoter of this step, but this is just a definition of congruency again. So we went from here to here pretty much. Congruent to equals. That's all we did. Now the last step here, we can say C is midpoint of lines AB. we can go straight to this guy and just put it right there, right? And we can say a lot of reasons here. We can say definition of midpoint if you want, or we can even use the theorem, the midpoint theorem, right? Theorem 2.1, same thing, okay? So you can rewatch this video as many times as you want, fast forward it, pause it, whatever. And your homework's at the bottom here, guys. Sorry you couldn't be in class, but have at it.